Welcome to Notes 8.56. Today we are going to be talking some more about quadrilaterals, but these are quadrilaterals that are not parallelograms. So before we talked about parallelograms and all of their properties, and then we talked about special parallelograms, which were rectangles, rhombuses, and squares. Now we're just going to be talking about special quadrilaterals. And we are going to begin with a bunch of definitions, so prepare to copy. First, we have a trapezoid. Whoops. That did not go well. Let's try this again. And a trapezoid is a quadrilateral with one pair of opposite parallel sides. We call those parallel sides the bases, which would mean the two non-parallel sides are the legs. Trapezoids have base angles, and base angles are formed by the same base and the legs. All right, so let's draw a trapezoid, shall we? Okay, so I got two parallel sides. There's one, there's another one, and then I have two non-parallel sides. Okay, so these guys, this is a base, this is a base, this is a leg, this is a leg. And then if I'm talking about the base angles, I'm either talking about this angle and this angle, which are formed by the same base and the leg, or this angle and this angle, which are formed by this base and the legs. And in an isosceles trapezoid, these two legs have the same measure. So they would be something like that. And when that's true, then what I've drawn here with these angles being congruent, that becomes true. So isosceles trapezoid is a trapezoid with congruent legs. And then a mid-segment of a trapezoid essentially is this black line that's drawn right here. It connects the mid-segments of the legs. And yeah, there was a semicolon. I thought that meant there was more, but apparently there's not. We will learn something about how you find the midsegment of a trapezoid a little bit later on. Oh, I lied, totally more. It's parallel to the bases, and the length of it equals the average of the bases. So you add the two bases together, divide by 2, that gives you the length of the midsegment. All right, and then the last special quadrilateral we're going to talk about is a kite, and a kite is a quadrilateral with two pairs of adjacent congruent sides. And we all know what a kite looks like. We flew them in our childhood. So we've got these two sides, which are adjacent, and they are congruent. And then we have these two sides, which are adjacent, and they are congruent. And that is my kite. As I referred to earlier, if a trapezoid is isosceles, then each pair of base angles is congruent. All right, so if the legs have the same measure, then the base angles are congruent to each other. And therefore, if a trapezoid has a pair of base angles that are congruent, then it is an isosceles trapezoid. Furthermore, a trapezoid is isosceles if and only if its diagonals are congruent. Right, if those diagonals are not congruent, then it is not an isosceles trapezoid. Okay, we need to show that CDEF is a trapezoid. And the thing that makes a trapezoid is it has one pair of parallel sides. So let's prove these sides are parallel. How do you prove things are parallel? You use their slope. So I need to find the slope of, and we know that these two would be the sides that were parallel if they were. So I need to find the slope of DE, and I need to find the slope of CF. All right. I can either use the formula, or because I'm given a graph, I can just count. So this one has a rise of 1 and a run of 3, so 1/3. This one has a rise of 2 and a run of 6, so 2/6, which also equals 1/3. So we have one pair parallel sides. Therefore, we have a trapezoid. All right. In theory, we need to prove that the other pair of sides are not parallel, but you can see that the slope of CD is positive and the slope of EF is negative. So we know right off the bat, without even having to find their slope, that these guys are not parallel. All right, so the way we prove a trapezoid is we prove that there are one pair of parallel sides. As we said earlier, when we were talking about the definition of the midsegment of a trapezoid, we said it was parallel to each base, and its length is 1/2 the sum of the lengths of the bases, or the average of the two bases. So MN here is a midsegment because it connects the midpoint of this side to the midpoint of this side. And we know those are the midpoints because they cut it into two congruent pieces. So MN would equal 1/2 of AB plus CD. So if we need to find MN, it would be 1/2 of 16 plus 9. So that would give me 25 halves, also known as 12.5 inches. Pretty straightforward. All right, let's talk about some of the properties of our special quadrilaterals. If a quadrilateral is a kite, then its diagonals are perpendicular. So now we have a rhombus that has perpendicular diagonals, and a kite has perpendicular diagonals. So you can't say just because diagonals are perpendicular that it is a rhombus or a kite, okay? You've got to figure out what else is true. So rhombuses are not the only quadrilaterals with perpendicular diagonals, I guess is the point that I'm trying to drive home here. All right, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So let's talk about this one a little bit. So we talked earlier about the kite. So it has two pairs of adjacent congruent sides. And let's mark those. So these two are congruent, and then these two are congruent. And then we just said that the diagonals are perpendicular to each other. So let's draw a diagonal and another diagonal. And that doesn't look perpendicular, but if I mark it, it's got to be true. So now it's perpendicular because I marked it. All right, so the angles that are congruent are the ones that are between the two non-congruent sides. So this angle right here would be congruent to this angle right here. These two are not congruent. And you can tell because if I look, this triangle right here is congruent to this triangle right here by side, side, side. They share this side, which means all of their corresponding parts must be congruent, which means that this angle is bisected and this angle is bisected. But if I look at this triangle right here and this triangle right here, those two triangles are not congruent, which means that these corresponding parts would also not be congruent. All right, and finally, if a quadrilateral is a kite, then the non-congruent angles are what I just said was bisected by the diagonals. Make sure you understand all of these thoroughly. Okay, we need to classify this quadrilateral and then find the measure of angle T. So first off, we know that because it has two pairs of adjacent congruent sides, it is a kite. And then we need to figure out what the measure of angle T is. Well, angle T, because it's between the two non-congruent sides, is going to be congruent to angle R. Those are the two angles that are congruent. And we know because this is a quad, altogether this should add up to 360. So we know that 70 plus 88 plus x equals 360. So all we have to do is solve for x. Please do that now and come back when you have an answer. Hit pause. All right, you should have gotten that the measure of angle T was 101 degrees. Okay, we have quadrilateral WXYZ, and it has both pairs of opposite sides congruent. We need to know what type of quads meet this condition. Well, both pairs of opposite sides congruent, obviously we are talking about parallelograms. All right, and if it's a parallelogram, then underneath the category of parallelogram, we've got rectangles, and we've got rhombuses, and we've got squares. All right. Can this be anything other than a parallelogram? Can it be a kite? Well, the definition of kite is two pairs of adjacent congruent sides, but it doesn't say anything about the opposite sides not being congruent. So technically, some kites, so sometimes, very rarely, but sometimes kite. What about a trapezoid? Right? No, trapezoids do not ever fit this category because if all four sides of the trapezoid are congruent, then it's no longer trapezoid. Trapezoid has only one pair, and if it had two pairs of congruent sides, it would be a parallelogram. All right, so sometimes kite falls under the category of parallelogram, although very rarely. All right, these next three questions I want you to answer in the notes check. So this will be question 1, and I want you to tell me the most specific name for quadrilateral ABCD. All right, obviously quadrilateral fits, but I need to know the most specific name. And then tell me if this is enough information to show that FGHJ is an isosceles trapezoid. Why are we not? This is going to be an essay question. I want you to be thorough. I want you to tell me why it's isosceles, if it is, and why it's a trapezoid, if it is. So I need you to address both parts of that question. And then finally, I want you to tell me what kind of quadrilateral it is. That'll be the first part of this question. And then how you proved that. How do you know? Will be the second part of this question. Okay, so 4 is how did you prove? All right, that concludes the notes for today. Please be sure to go on and do the notes check and ask if you have any questions in class. Thanks.